Hello, chemistry students. So today we're going to be talking about stoichiometric relations. I think that this is a really important thing to get down. It's one of the first things you learn, and it'll make your life much easier if you know, you're solid in this. Okay, so stoichiometry is a big word. What is stoichiometry? So Google says the relationship between the relative quantities of substances in a chemical reaction. That, to me, like just reading that, I had to break that down in my head. I think that's kind of complicated. So, relative quantities. When I think of that, so it's like, it's gonna make sense. It's gonna be like these are the relative quantities that they're speaking of, the 2 and the 3, the coefficients. And then of the substances in the chemical reaction, this whole thing, chemical reaction, and the substances, the molecules. So it's, and the relationship between them, you will see later throughout the video. It's going to make sense. It's going to click. It's going to be like, oh, okay. Okay. All right. So important things to keep in mind. Coefficients is one of them. Just to know what a coefficient is, it's good. I know people who don't know what coefficients are, and there's probably somebody watching this who doesn't know what a coefficient is, and that is perfectly fine. I'll teach you right now. A coefficient is this number and this number. It's just any number in front of the molecule, and if you think about it in terms of math, it's any number in front of the variable. I'm sorry. Okay. Now always convert to moles first. When you're in stoichiometry, that's very important. If they could be asking you to go from grams to liters, and you can't just hop straight there. You have their steps, and one of the first steps is converting to moles first. Well, how do I convert to moles? From going from grams to moles or moles to grams, you're gonna pull out that periodic table, and what you're gonna be using it for is just this number, the atomic mass. My bad. Boron's atomic mass is 10.881. There's carbons, nitrogens. So you're going to be using that number in your window when you convert from moles to grams or grams to moles. And then liters to moles and vice versa. If it's at S2P, then it's going to be 22.4. Very easy, very simple. And I'll just let you soak that in. Alright, okay. So now that we have all of that important stuff out of the way, let's try one. So, how many grams of NH3 are produced from 4 grams of N2? N2 plus H3 equals 2NH3. So, we are going to be going from here to here. So let's get started. All right. So I as you see, I already wrote down. I got it started for us. So the starting point, where we know it's going to be 4 grams of N2 because it wants to know how much is produced from 4 grams of N2. And okay, so the reason I put this 28 grams of N2, it's like, okay, where'd you get that from? What's happening? Periodic table, because what are we doing? We're going from grams to moles first. And here you are. Well, where? Oh, 14 is nitrogen's atomic mass. So the reason that it's 28 is because it's N2. Now, if it were just N, then it would just be 14. You just put 14 grams of N, but it's N2. So you times that number by 2 because there's 2 nitrogens. So now these would cancel each other out. So now we're gonna have left with 1 mole at the top. And awesome, yay, we've converted to moles. Now what do we do? Now we're gonna do our Stokes step, as I like to call it. And you're gonna put 1 mole of N2, because all of this is still N2. And you're going to put 2 moles of NH3 2 moles. These are the moles. These are the moles of the problem. And remember, 1. This is a 1 because there's nothing in front, so you assume it's a 1. And now you have the Stokes step. So now we're in the clear. You're in NH3, but it asks for how many grams of NH3. Now you have how many moles after you solve it. So let's just extend that, and you're gonna put 1 mole of NH3 because when you're converting, the reason you just put 1, it's like, well, why did I put 1 here? Why did I put 1 over here? You do that because, like, 1 mole is equal to, you know, however many grams and all this stuff. So that's just your conversion factor. So you're gonna put 17 grams up here of NH3. Well, wait. How did you get that 17? Where did that come from? I don't see that anywhere in the problem. Well, keep in mind, it's NH3, and you're going from moles to grams now. Notice how, you know, the numbers flip-flop, how I said you could do vice versa. So you're gonna pull out your periodic table. Well, here's nitrogen over here. It's 14. And I like to round, so I just rounded to 14. And then here's hydrogen over here. And it's 1. Nope, not focus it. It's 1. And it's 1 times 3 because there's 3 hydrogens, so 1 times 3 is 3, and then 14 plus 3 is 17. And when you multiply everything across the top and multiply everything across the bottom and divide those two, your number that you get is 4.85 grams of NH3. And you found your answer. Awesome. I'm sorry, you didn't even see me writing that. Thought you did. And there it is. So now let's try another. Okay, so here is another one. How many moles of oxygen are produced from 12.0 moles of potassium? And notice, oh yeah, this is easy because it's going from moles to moles. It's gonna be quick, easy. So what are we gonna start with? We're gonna start with what we were given, 12 moles of potassium. Just gonna put that K there. And then, so now you can go right away to your Stokes step because you have your 2 right here, and you have your 3 over here. And since you're in potassium, you're gonna use this coefficient first. So you're gonna put your 2K down. Well, 2 moles. Okay, I'm sorry. 2K. And then you're gonna put 3 moles of oxygen at the top because that's what you're going to. And now, when you do all your math at the end, it equals 18 moles of oxygen. And oh, did I find what I was looking for? Yes, you did. How many moles of oxygen? You found it. So yes, thank you so much for watching. I hope I helped, and I hope the paper that I used did not give you a headache. Thank you.